Good afternoon. We're going to review the factoring patterns that we've covered so far in the chapter, as well as one of the factoring patterns that we're going to learn next week. So remember that all factoring fits into a process that looks like this. You always start by factoring out a monomial, regardless of what factor pattern you use after that. So the first pattern we're going to review is how to divide out a monomial. And factoring is division, division is factoring. So this is a type of factoring. So I'm going to do an example. 3x cubed plus 6x squared minus 12x. Now sometimes when these are simple, you can do them in your head. You'll know what to divide out. Other times you want to make especially sure that you're dividing out everything you should, in which case prime factoring each of the terms would be a wise decision. I'm going to demonstrate that. So 3 is a prime number and x cubed is 3x's. That's prime factored. Plus 6 is 2 times 3 and it has 2 x's. There it's in its prime factored stage. For the last one, it's negative, so we use a -1 placeholder for the negative. And then 12 is 4 times 3, or 223, with an x. Once you've factored everything out, it's really pretty easy to spot what they have in common, and that's what you want to divide to the front. So all three of these terms have a factor of 3, and they also all have a factor of x. We can't divide anything else out because this term only has a 3, there's nothing else. This term only has one x and nothing else. So this is all we can divide out. The 3 and the x go through the front of the parentheses, and now we divide out our factors. So 3's divide out, x's divide out, and you're left with x times x plus 3 divides out, x divides out, 2 times x, and then here divide a 3, divide an x, we have a -1 times 2 times 2. So multiplying the factors back together, we get 3x times the quantity, x squared plus 2x minus 4. And this doesn't go any further than this. So this would be our answer. This is factored. Okay, so in the factor process, after you've divided out a monomial, you need to count the terms. So if there are 2 terms, it's a binomial, and you're going to use the pattern difference of 2 squares. So our second review pattern is the difference of 2 squares. And this has a formula that goes with it. If you have a perfect square, a squared, minus a perfect square, b squared, it factors into a plus b, a minus b. So an example of this would be 4 minus 9x squared. So there's nothing to divide out. You've counted the terms. There are 2 terms, and there's a negative in the middle. That means it's highly probable that it's difference of 2 squares. So the test for difference of 2 squares is, can you write it as something squared minus something squared? If you can, it fits the pattern. Okay, so 4 is 2 times 2, or 2 squared. 9 is 3 times 3. And x squared is x times x. So yes, we can write this as a difference of 2 squares. So our a term is 2. Our b term is 3x. So following the pattern, this is going to factor into a plus b, 2 plus 3x, and a minus b, 2 minus 3x. You always double check for expansion, but this doesn't expand because this one has a plus in it, so that doesn't meet the pattern. This one has the minus, but 2 isn't a perfect square. And that would be your factored answer. Okay, so The third factor pattern we're going to go to, and I'm going to go to the top of a new piece of paper. This is the longer one. So you factor out a monomial, count the terms, and let's say it has 3 terms. It's a trinomial. That is going to be regular ABC factoring. So our third factor pattern is ABC factoring, which is the one we spend the longest time learning. It's also the most common. All right, so for example, we'll start with a simple ABC factoring, something like x squared plus 2x minus 3. All right, in ABC factoring, you have to first label A, B, and C. So in this case, A is 1, B is 2, and C is negative 3. So your first step is to factor A into all possible combinations of numbers. Well, A is 1, so 1 times 1 or negative 1 times negative 1. Now, we never use double negatives on the A, which means our factors of A are 1s. And this will come in handy here in a second. Now we list factors of C. It's a negative 3, so 1 times negative 3 and negative 1 times positive 3 are the only 2 possibilities for a negative 3. Now normally you'd have to be testing factors, but remember the shortcut. If your A's are 1s, then your C's will add up to our B value by themselves. So if I take 1 minus 3, I get negative 2. That's not our B value. If I take negative 1 plus 3, I get a 2, and we have a winner. There's our 2 factor pairs. Okay, so we're going to draw our sets of parentheses, and A's go in the first position. So 1 and 1, and then if it has a variable, split it, x and x. Factors of C go in the second position, which is negative 1 and 3. The last thing you want to do is make sure that your C's are in the correct spot. We learned something that we nicknamed rainbow check. Rainbow check is a shortcut to multiplication. So let me rewrite this, x minus 1, x plus 3. In rainbow check, you multiply the inside 2, which is negative x, and the outside 2, there's the rainbow, which is 3x. Add them up, you get 2x, which is our B number. And it's just a way to check your C's. So this factorization here is your answer. You can leave the 1s in or take them out. X minus 1, x plus 3 is the same exact thing. Okay, so that's a really easy ABC factoring when the A's are 1s. So let's go to a second example, which is a little bit less simplistic. Let's say that we're using 6x squared minus x minus 2. There are 3 terms, so this is regular ABC factoring. A is 6, B is negative 1, C is negative 2. So if I list factors of A, I get 1 times 6, negative 1 times negative 6, 2 times 3, or negative 2 times negative 3. We can eliminate the double negatives on the A term. Now factors of C. C is negative 2, so 1 times negative 2, negative 1 times positive 2. And that's pretty much it for factors of C. So those are your factors of C, those are your factors of A. Okay, so this is where we're going to start to test factors, and we want to know what combination is going to add up to the B value, which is a negative 1. And this is where you have to guess which factors you think they are. I'm going to guess this one, and then I'm going to guess it might be this one. So when you've picked your guessed pair, you need to test them 2 ways. So the first way to test them is first terms and second terms. So I'm going to multiply the first terms, 2 times 1, and then I'm going to multiply the second terms, 3 times negative 2. 2 minus 6 is negative 4. That's not it. Now before we eliminate, we want to test them out the other way, which is insides and outsides. So here we go. Inside terms, 3 times 1, plus outside terms, 2 times negative 2. So 3 minus 4 is a negative 1, and we have a winner. So if that hadn't worked, we would then want to try to pair this with the second option. If it didn't work both ways with the first option, and it didn't work both ways with the second option, you would know that 2, 3 is not a factor pair, and you'd have to go to 1 and 6. If nothing works, it's not factorable. As it is, though, we did find our winning pair. So draw your parentheses. Factors of A go in the first position, so 2 and 3. There's an x squared, so we split the x. And just for the fun of it, let's put a double letter in here. Let's change this to a 2y squared and this to a 1xy. So the only difference that that's going to make is when you put your c term in, which is positive 1, you'll split the y's. So 1 and negative 2 split the y's. So split the y's for the a, split the x's for a, split the y's for c, and you've got it. Okay, so the most complete way to check your answer to make sure that it's correct is to remultiply. So we're going to run a check. We're going to multiply 2x plus y times 3x minus 2y. We're going to use distribution property. So to begin with, we're going to take the 2x and multiply it by both of the terms in the second parentheses. So let's do that. 2x times 3x is 6x squared. 2x times negative 2y is negative 4xy. Then you move to the next term over, in this case the y, and you distribute the y. Multiply the y by both terms in the other parentheses. Here we go. Y times 3x is 3xy. Y times negative 2y is negative 2y squared. In a trinomial, the middle will always have matching letters. If it doesn't, there's a problem. This is 6x squared minus xy minus 2y squared, which matches what we started with. That means that we are 100% certain that our factorization here is correct, because multiplying checks everything. The rainbow check, which we looked at before, will check to see that the c's are in the right spot, but it won't actually check the entire factorization. All right, so that is ABC factoring, easy and then more challenging. The last pattern we're going to look at might be new for some of you, which is factor by grouping. Factor by grouping. Okay, factor by grouping fits into our patterns because when you count the terms, you end up with 4 terms, which is a quadnomial. That's when you use factor by grouping. So here's an example of factor by grouping. ax plus bx plus ay plus by. So the way you factor by grouping is you designate 2 pairs. So I'm going to designate 1 pair and 2 pairs. Then you divide out whatever you can out of those 2 numbers. So out of ax and bx, I can take an x out of both of them. The x goes to the front, and I'm left with a plus b. On the second pair, I can take a y out of both of them. So we put a positive y at the front, and we get a plus b. This is exactly like dividing out a monomial, our first factor pattern, just you're doing it in pairs. Okay, here's the fun part. Both of these quantities, here and here, have two factors. A monomial in the front and a binomial that comes second. The binomial is a factor that they have in common. So we can divide that out just like we did the x's and the y's. And the a plus b will go to the front. And you're left with x plus y. And that is factor by grouping. I hope you enjoyed this review and that it was helpful to you. Have a good afternoon.